Hey everyone, and welcome to this third lecture in the series of lectures on probability. In the previous two lectures, we already covered the introduction to probability, the basis of probability, and how probability is used in our daily life. Then we covered permutations. We saw the definition of permutations, the formulas related to permutations, and how permutations can be used in everyday life. In this lecture, we'll be talking about combinations. So we talked about permutations, that we said that in an arrangement or listing in which an order is important is called a permutation. Now the combination is exactly kind of an opposite to permutation. A combination is basically an arrangement or listing in which an order is not important. So if you have, for example, or the example over here, if you can see that if you are choosing two salad ingredients from a list of 10, and it does not matter which ingredient do you choose first, that is that the two ingredients that you're going to choose, it doesn't matter which order you choose the two ingredients in. If that is the case, we're going to use a combination. There will be the combination of the two ingredients that we're going to select from the list of 10 ingredients that we can have for the salad. Had there been a question in which a listing had there been a question in which the order was important, then we would have used a permutation. Now just like permutation, combination also has a formula through which we can solve the questions related to combination. We saw in the permutation lecture that the permutations also had a formula similar to this one. The main difference, as you can see over here, first of all, is the difference between the symbols that we're going to use. Instead of NPR, we're going to use NCR, because that was permutations and this is combinations, so we're going to use C instead of P over here. And of course this formula looks a bit different from permutation formula as well. Why? Because we have introduced this new term r factorial in the denominator. So we have now n factorial over n minus r whole factorial and then into r factorial. Now this is the formula that we're going to use for combinations. We're going to use this with the help of, I'm going to show you with the help of an example how to use this formula. Another thing I wanted to say was that after we're done with combination, we're going to go to the fundamental principle of counting. We're going to see slides related to that, and we'll be covering that as well. So now let's look at the first example over here that we're going to select and then we're going to solve. The first example is that the students of Mr. Fan's seminar had to choose 4 out of 7 people who were nominated to serve on the student council. Now this is basically the statement. Now what do we have to do is that we have to find out that how many different groups of students can be selected. One thing that we have to keep in mind is that over here we know that since we are solving this for a combination and we're trying to find out the combination, right? So we know that the order in which the students are chosen does not matter. Now I want you to stop for 1 second and concentrate on this, that how would you know that to use a permutation or combination? Of course over here I can tell you that since we're covering up combinations, you know that we can use a combination, and you know that since we are covering combinations, we know that all the questions involved would be the questions in which an order is not important. But what about in the real life? By real life over here I mean that what about in an exam? What about the question that you get and you have to find out the answer to this question, like how many different groups of students could be selected, and you don't know what to do, whether it's a permutation or it's a combination. The way to find that out is that the only way to find it out is the best way, in fact, is that you look at the statement of the question and you try to visualize it. Now once you have done that, once you would visualize the situation, you would know whether the order was required or not. For example, over here you're required to select 4 students out of 7 for the student council. Now the question does not say 4 students in particular order, 4 students by age or by experience, or 4 students, 2 students of this kind, 2 students of that kind. It doesn't say that. It just says 4 students. It's a general thing. So now through this statement you would know that the order does not matter in this case. Since the order does not matter, we can find out the answer by the help of a combination. Now let's go ahead, and this is true for all the questions you're going to get for permutation combinations. Of course, if you know that the particular question is related to permutation combination, you can just use the formula for that. But if you have a question just like this, most of the time you're just going to have a question. You're just going to have a statement like the statement shown on the slide, and then you're going to have how many different this can you form out of this, how many different ways can you do this, and then you will have to find out on your own whether to use a permutation or a combination. Now since we know that NCR over here, n is going to be the total number of options that we have, and 4 is the selection that we're going to make, so we're going to write it down first of all in the proper syntax, and that is going to be 7C4. After we've done that, we write it down in terms of the formula. We know that n is equal to 7, so the numerator is going to be n factorial, that is 7 factorial, and the denominator is going to be n minus r whole factorial, that is 7 minus 4 whole factorial, into r factorial, that is going to be 4 factorial. And now of course you can solve it with the help of a calculator, but rather than using calculator, we will expand this. Because it will become really easy for us to solve. So 7, as we already talked about factorials, 7 is going to be 7 into 6 into 5, 4, 3, 2, 1, and 7 minus 4 whole factorial is going to be 3 factorial. It's going to become 3 factorial, and 3 factorial is going to become 3 into 2 into 1. And then 4 factorial is of course going to become 4 into 2, 3 into 2 into 1, and then you basically cut out the like terms from the numerator and cancel out the like terms from the numerator and the denominator, and then you get this 7 into 6 into 5 or 3 into 2 into 1. With that, you have your answer. Yeah, there are 35 different groups of students that could be selected. What does this mean in real life? This means that if you start choosing from these 7 people, there will be 35 different combinations of students that you can make as a nomination for the student council. Of course, you can have 1 student and 3, and then those 3 can go out, and the next 3 can come in because they're all together of 7. And then the first student can go out, and one of the 3 can come in. Just like that. It is exactly like what you do in real life. The combinations that you do in real life. The only thing that we have done is we have simplified it. We have represented in mathematical notations, and so since it has become this easier now, this is how you get the answer to this. Now, one thing that you need to remember, that we are basically done with permutation and combinations right now. We're going to go to the fundamentals principle of counting, but of course before that, I would just like to say that when a question like this comes about finding out a combination or a different arrangement, what I want you to do is first of all read the question. Try to visualize it, because once you visualize it, that is the only way you could find out whether it is whether you have to use a permutation, whether you have to find a permutation or a combination. Of course, you have to find an arrangement in the end. You have to find the different ways in which you can solve a question. But what you need to do is how to get there by the help of a permutation or a combination. And that you can do by visualizing the question and looking at the wordings of the question, whether a particular order is required or it isn't. If it isn't, of course, you know, then it will be a combination. If it is, it would be a permutation. So this is pretty much it with the permutation and combination. So now let's start with the fundamental counting principle. As the name suggests, it is a way to count different stuff. It is one of the things that we need to know in probability. Officially, this was not a part of your curriculum that that we were thinking of teaching you, but this is so important that we already discussed this in the permutation slides, that I thought that I should go over this so that you would understand that better. And of course, since it's a new concept, its knowledge is going to help you as well. So what is the fundamental counting principle? Fundamental counting principle is basically a rule for finding the number of possible outcomes. Let's just say if an event has m possible outcomes, and another independent event that is not has m possible another independent event that is not connected to the first event, that is, you will have m possible outcomes, but another event that's going to have n possible outcomes that's not connected to m, that's not connected to the first answer, that the first number of outcomes that we got. So then there are basically m multiplied by n possible outcomes of the two events together. We're going to go through some examples to show how this works, but basically if you have try to understand, and this goes for more than two outcomes as well. For example, if there was an A event and there was an independent B possible outcomes, and then let's just say there was a C number of possible outcomes. Once you have seen that M and A and B and C, you would know that the answer to that would be similar to this one, and just like, because we have 2 over here and we have 3 in the example that I told you, it's going to be A into B into C. That is the number of possible outcomes of the 3 events altogether, 3 events added together. So moving on, now let's just say, take an example. Let's say that you want to flip a coin and you want to roll a die. Now these are 2 independent events: rolling a die and flipping a coin. These are 2 independent events, just like M and N that we saw in the previous slide. So there, how many ways, how many outcomes can can a flip of a coin have? There are altogether 2 number of outcomes that a flip of a coin can have. And how many outcomes can a roll of a dice have? A roll of a die can have basically 6 outcomes. So what is the total number of outcomes? M into N, that is 2 multiplied by 6. So there are altogether 12 ways that you can flip a coin and roll a die, and it's really basically common sense. I mean, if you flip a coin and you get a heads, then the first thing is that you get a heads, and then you get 6, any of the 6 digits on the die, and just like that, let's just say if you flip a coin and you get tails, and then you can get the 6 from the roll of a die as well. So altogether that become 12 possible outcomes. So this is the fundamental counting principle. Now let's say, take another example. If you want to hit 1 note on the piano and play 1 string on the banjo, so there are 88 notes on the piano and 5 strings on the banjo. So you can either get 88 either of the 88 from the piano. So basically their outcomes in the first case over here are going to be 88, and outcomes on the second case, that is the banjo, are going to be 5. So what is the way to do that? The way to do this is basically 88 into 5. This is pretty straightforward stuff, but this is known as a fundamental counting principle. Now let's move on. So if you have a deck of cards, 52 cards without replacing them, and you're not going to replace them, so that means once you get take out 1 card, you're going to be left with 51 cards. So if you want to draw 2 cards, the first thing that you're gonna get is that you have a chance of getting any of the 52 cards. So basically, for the first time that you're gonna take out a card, you have how many outcomes? 52. Now since it is not going to be replaced, the second time that you're going to take out a card, the number of possible outcomes is going to be 51. Now this topic also comes under the introduction of probability. I didn't cover it then, so I'm covering it now. So you see, now an interesting thing is, what if you were to take out a card from 52 cards that you have a deck with you, and you have the possible number of outcomes would that then be 52, of course. What if you replace that? Rather than keeping it outside the deck of cards, what if you put it back? What if you don't replace it? What if you put it back? What will be the second number of outcomes that you can have? The second number of outcomes in this case would once again be 52. Why? Because the number of cards is once again 52. In the example that we are looking at in the slide, the number of cards for the first try are 52. So we take out 1, and then the number of cards are 51. So the second time we want to take out the card, we're only left with 51 cards. So since we're left with 51 cards, we would only have 51 number of outcomes. So 52 multiplied by 51 is going to be the ways of drawing the 2 cards. Now let's move on to the next slide. A phone number is a 7-digit number assigned by a phone company. We all know that. How many different 7-digit phone numbers can be assigned? Now there are 10 digits as possible outcomes for each placement in a phone. So 10 into 10 into 10, 10, 10, 10, 10. This is 7. So we know that there are basically these many possible outcomes for a 7-digit phone number. So the purpose of this example is that you don't get scared from a very large number. Just go with your intuition, go with your common sense, go with what you see around you, go what you think is right, and this is pretty simple. This is pretty basic. Now if you have this possible outcomes over here, these are the combinations that you have. So this is I'm pretty sure that most of you have already gone through this dilemma at some part of your life. So you have 3 shirts, 2 pants and 3 shoes, and you want to choose an outcome. So how many possible outcomes are there? So they're altogether going to be 3 into 2 into 3, 18 possible outcomes. Just like I say, I talked about in the first slide about A into B into C, we have 3 possible number of outcomes, and we know what those numbers are, 3 into 2 into 3, and then we multiply it, and this is what we get. Now let's look at the last example before we finish this. Now this is another example I'm pretty sure all of you have had been with, have experienced in your life. So let's just say that you have 42 friends on Facebook. Anytime you access your profile, 6 of your friends will appear in a box below your picture. Each time these friends are randomly generated out of 42, how many different arrangements of 6 people can show up? So basically the first time you go, of course they're going to be 41. Now the one friend is gone, so you're left with 41. So once that friend is gone, you have 41 left, and once that friend is gone, you have 40 left, 39, 38, and 37. Basically the point of this example is that it's just like the card example, that you have altogether 42 friends. You're going to take out a photo of one friend, the profile of one friend. You're not going to replace it, so you're going to be left with one less and then one less. And once again, don't get scared by all of these big numbers. If the question makes sense to you, just go with your intuition, go with what you're feeling, go with your common sense, and I'm sure you're going to get the answer right. So that's pretty much it for the probability lectures. We're going to start with the sequences next, and hopefully I'll see you then. Bye.